When you had an initial velocity problem, you had the two types. You had the types that started at the ground, or you had the types that started at some varying height. The ones that we talked about that started on the ground, I think that one was like the cannon or the missile chute or whatever it was, the Big Bertha. There was that one. There's also the one where we had that Jackie Joyner Kersey was shooting the shot, throwing the shot put, where it started at an initial height value. It started at some value, some C value. Now remember, when you have an initial height, an initial spot, that's basically telling you that it's starting there. To y-intercept. The value of C when you have initial height, when you have initial velocity problems, if there's a value of C, it's always your y-intercept, because that's the starting point. Starting at some value of 0 before you throw it, and then you're shooting the shot put out. Okay? Yes, ma'am. No, we're going to wait on that for a couple of days. Okay? I'm in no rush to get to. I'm not in any rush to start the comic stuff. Okay? This isn't a big deal right now. So when you have this value of C, that's your initial height. In this word problem here, it says someone's juggling, throws a ball in the air, releasing it 5 feet above the ground, initial velocity of 15 feet per second, catches the ball with the other hand, the ball is 4 feet above the ground, using the model, blah, 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 blah. How long is the ball in the air? Okay. So where does the ball start? It starts at 5 feet. It starts at 5 feet. Notice that it has this negative A value. What direction is this curve going to go? It's going to go up and then down, correct? So we know that just from this part alone, not knowing how to do anything of it yet, I can draw a picture. And I cannot tell you guys the importance of being able to draw a picture of what in the world is going on. Doesn't matter about your numbers, but if you can kind of get the idea of what goes up must come down. So we know this is going to go up and down. Do I really need to worry about it coming back to a negative value?
No.
Because we're not really, when it's moving upward and it's going up and out, I'm not worrying about it falling behind me. Does that make sense? It's very rare that you'll ever have something like an initial velocity problem. You're trying to figure out where does it go behind you. Because it's just bad if something blows up and goes behind you. Now, it tells you this. You have this, excuse me, you're trying to solve to figure out when is the ball 4 feet above the ground. So that's what you're trying to solve for. You're trying to get 4 equal to this negative 16t squared. What was your initial velocity? 15 feet, so it'd be plus 15t, and then our initial height is 5.
Wait, but if the 4 feet is when it lands, why does that equal be?
You're trying to figure out when does it get to here, and how much. Remember, your time is this. Your height is this. You're trying to figure out when does this graph equal 4.
It says find how long the ball is in the air.
Right. So you're trying to figure out what value of time it gets to 4. How long does it travel? How much time is spent between here to here?
I guess my problem is I would look at this one problem and I wouldn't know to put that equal to 4.
What would you have done?
I don't know. Probably would have put it in the calculator and then gotten really confused and then skipped the problem. What?
I thought about it.
It's honesty. I appreciate the honesty. No, seriously. Yeah, screw it. I'm out.
I thought about it, and I was down to the because the ball is traveling in the air 1 foot, so 15 feet a second, it will travel it will be in the air. The distance will be matched at time 1/15 of a second. Is that how long the ball would go?
Not necessarily. And I see where you're trying to, you're analyzing this in terms of velocities.
Yeah.
You have to take consideration. Hey guys, you have to take consideration. It's not linear. If it was linear, that would work. But since you have an arc to it, isn't an arc longer distance than
straight line, yeah.
Exactly. But your thought process is good. I like that. So basically, there's a couple things you can do. Yes, ma'am. This is your velocity initial, or original. So V sub O stands for velocity original. Height sub O, or H sub O, is your initial height, your height original, if you want to think of it. Where does it start at? Now, Julie, one of the things is that I usually just gave you guys this formula, okay? That's why, if I have an initial height problem or something like that, I'll give you this part, but you might have to figure out what to do with the 4, okay?
I don't think that, like, figuring out, because I mean, we know that, like, I want to come to something like y-intercepts, if that's where it starts, then it's going to go in, like, the alien.
Yeah.
Like, so I mean, like, I don't think that
It's
part
not
is the hard
terrible.
part.
Yeah, it's not
The hard part
terrible.
is knowing what
It's
to
not
do.
terrible. Yes, sir.
So, can't you subtract 4 from the 5 and put it instead of 0, moving to the quadratic?
Absolutely, that's one quick way to do it. So a couple things you can do then is, if you set this equal to 0, now I know that some of you guys did send out and got the quadratic formula song stuff there. I'm not lying, I'm sorry, I did not get a chance to, I haven't watched all of it yet, I will. I was hoping, I have them all saved to the side there so I don't lose them and all that. But I will go through them, and I promise you guys we'll watch them in class, and we'll laugh at each other and make fun of each other. It's gonna be, what's that? No. I forgot, guys, did your mom do a cameo? That'd be awesome if your mom did a cameo. Be fun. So, trust me, there have been some absolutely horrible ones, and they're just, I mean, look at Christina's. I mean, the bar is set so low. I mean, she's short, so it's really easy to jump. Oh, and I know you guys are going to tell her, she's going to walk in here and flex, go, you're making fun of me. Like, whatever, we're skiing. So, in this case here, I would just use, like you were saying, just use quadratic formula. It's quicker. Okay. Now, when you do the quadratic formula one, let's sing the song. X equals negative b plus or minus square root b squared minus 4ac all over 2a.
Can you just say it like it's not a song? It's just like
No, I can't count like it's a song. I can't do that as like it's a song.
Go 1, level 2, level 3.
Sir, yeah. Yes, sir. Sure, if you want to. Absolutely. Absolutely. If you want to factor, go ahead. Remember, guys, you can complete the square if you're so inclined. I wouldn't, but you could. I see this and I'm going, hey, you know what, I use this. And think about what we have here. When you're talking about time, and you're talking about a quadratic, you're probably going to have a positive and a negative value. You know right off the bat which one to throw out when you're dealing with time. What would you what would you throw away?
Negative volume.
Correct, because we're not in a DeLorean doing 88 miles an hour. So, was it isn't the square root of 289 like 17? All right, so we have negative 16, I'm sorry, positive, wait, I'm writing the wrong thing here. 15 negative plus or minus 17 all over negative 32. Okay.
E equals 1 because the opposite value is negative 160.
When you pop them through here, we get negative 15 plus 17 would be 2 over negative 32, which is negative 1/16, which, can we have negative 1/16 time? No. That answer is not going to work. If I do negative 15 minus 17, I get negative 32.
Over negative 32, which is 1.
And it equals, how much time elapsed?
1 second.
1 second. And see how you were saying
If I
it.
put that calculation on a calculator and went to the table with 1 second.
I believe so. Let's see here. If I go to y equals, and if I throw that in my y equals table, and I do negative 16x squared plus 15x plus 1, go to my table. Dun, dun, dun. Hey, look at that. Where's your 0? 1. Okay? If you graph it, oh, it's a tough graph to see. It's tough to see that graph, how it goes, because it looks like it's hugging the x axis. Thank you, I forgot what it's called. Math term. It's hugging the math term, and I forgot. So yeah, that's one of the ways that we can interpret our data. So there's numerous ways to go about solving the problem. Now, if you guys factored it, obviously you could. What times what's negative 16 you add together to get 15? Well, 15 or 16 and negative 1. It is a factorable problem. Knowing myself, I don't like to factor problems that have negative a values. I always screw those up. So I'm not going to do that. That's just my own personal way of avoiding that problem. Okay? Yes, ma'am.
I guess the only thing that I know that I would struggle with is like knowing to set 4 equal to the.
And that's the thing. When you look at the problem here, it asks you, she catches the ball in the other hand, the ball is 4 feet above the ground. Using the model, height is blah 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 for how long the ball is in the air. So you're starting at 5, and you're trying to figure out how long it takes for the ball to get to 4. What Mr. Decker was bringing up earlier, and that's the idea again, is knowing what this looks like graphically, that you have some initial height here at 5, the ball's going to go up and down. If this is at 5, you're looking for when does it cross here at 4, and your x values here is time in seconds. So you're looking for when does it start at 0, so how much time elapsed, not at that, but how much time elapsed to get to here. That's what that is interpreting. It takes 1 second for the ball to go up and down. As opposed to what you were saying, if it was linear, it would be that 1/16 of a second or 1/15, yes. So, but it's going up. Gravity, I hear it's a problem.
That's a fast ball, 15th of a second.
Yes. Are you making fun of my
Because you make fun so often.
Wait, why did we do the quadratic formula?
It's another way of doing it. Yeah, it's negative 9.8 years per second squared, plus negative 16. Quadratic formula, remember, it's always going to work. Quadratic formula is always a way to find zeros and find system out. Over time, what's nice with quadratic formula is that it's, if you remember the formula, it'll always work. It'll always get you a 0. So, hey guys, this is a good question. Why did we use quadratic formula versus the graphing calculator? Well, we could use the graphing calculator and calculate the 0. That would work as well. Now, the reason why, if I did that in the calculator, you'd have to remember how to go through all the sequence of buttons. Do you want me to walk you through the sequence of buttons again to remember how to do zeros? Do you remember zeros?
Yes.
Yes.
Kind of. Isn't it like alpha?
All right, let's do this. Let's all take a second. Let's put the same problem in the calculator to make sure that we get how to set it up, okay? Excuse me. So, what do we have? Negative 16x squared plus 15x plus 1. And just go right to our graph. Okay? Now, right now, my window's probably all sorts of messed up. So, what was the easy way to put a window setting, just start, like a starting point window setting?
There was one that was like to fit the graph.
Zoom Fit it works out too, but I think doesn't Zoom Fit kind of obstruct it a little bit? Or does it?
It always puts it at the top.
Yeah, I'm not a big fan of that. Zoom Fit's fine, because at least that way gives you a starting point to go through it. Personally, I'm looking at this and I know that I know I have a y-intercept of 5, because that's what my C value is. I'm going to do my regular boring 10 by 10, just to get an idea. Okay? Remember, to change your window, negative 10 10.
Mine's already at that.
Oh, that's fine. Mine was changed from earlier from a different problem. You go back and forth on it. So looking at that, yes ma'am? I typed in the negative 16x squared plus 15x plus 1. It was equal to 4. We moved that 4 over to set it equal to 0. So anytime we're going to go something in our calculator to find zeros and stuff, when we're trying to find a 0, we're going to make sure that it equals 0 on the other side. Okay. Yes, ma'am? You done too. Oh, you went there's a problem. Yeah, when your Y maximum is 96 million, anything might look like a little bit of an interesting problem. Yeah, kind of zoomed it out a little bit. Yeah, is that zoom fit?
No, that's,
Oh.
I put in the equation, and then I got that the y-intercept is 1,
Okay.
not 5. So it's going up and
Well-
up and down.
Well, remember, we moved it over to set it equal to 0. We set it equal to 0, so we switched it over. So now, to calculate the 0, I'm going to hit second, calculate, option number 2. And then it's going to ask you a series of questions.
Wait a second. What did you like?
Second, calculate, option 2. It's going to ask me a series of questions. It's going to ask me it's going to ask me for my left-handed boundary. Now, I'm looking to find the 0 on this side, on the right side. So it means my cursor needs to be above the x-axis. A real easy way to figure out your above and your below portions are to move back and forth and notice how your y values switch from positive to negative. That's about as close as I can get, so I hit enter for that one. The right bound, I'm going to move it to the right. I'm going to hit enter for that one. I'm going to hit guess. I'm going to say it's probably 65 degrees out. And then I'm going to hit enter one more time. It's going to say my 0 is at 1.
As long as you understand how we got that answer.
Right. Yeah, exactly. Or, there's your fire alarm. Hey! Go to the stop sign! Go, 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 go! With these is when you have the quadratic word problem, the cost sales style, we have a bit of a disconnect when it comes down to what does X represent? Is it representing a sales figure? Is it representing a sale, like a number of sales, a number of items being sold? What does it represent within a problem? In these types of problems, you have to understand that X is a multiplier. That's all it is. It's a multiplier. The two separate pieces, the cost portion and the sales portion, are what X gets substituted into to develop what was the sales, how many pieces were sold. The X value is just your multiplier. That's all this thing works out to be. So if we go back to the shoe selling one. They sell 200 pairs of shoes when they charge $60. For each dollar increase, 2 fewer are sold. So your multiplier for these is that value of X. If you multiply it, if you're selling it 5 times fewer, it's taking $5 away, that means the X value was 5. If I sell $5 cheaper, I'm selling them for 55, and then, $5 more, so I'd be selling for 65, and then how many fewer pairs would be sold? 10. That's the relationship between. What's up?
This is the same problem that was on the back page of the test.
It was very similar. Very similar.
I knew exactly how to set it up, but then I had zero idea what to do.
Well, hopefully this will help remind ourselves. When we have this, we have our, one of the things I also noticed that a lot of you guys did, you wrote in here cost and sales. A lot of you guys did that right away on the 2 parts. It was great. I was very happy to see that. From this, you knew that you had cost of $60 and you sold 200. So at $60, you sell 200, your income would have been $1,200, okay? Just by multiplying those two values together. For every increase of $1, for $1 increase, that value of X is just representing the multiple times you're adding the dollar to it. If I add five times to it, I'm adding $5. If I'm adding 7, I'm adding $7, and so on. That would give me a new cost value. If I don't change the cost, my cost value is still 60. Okay? For every $1 increase, I lose 2 pairs of shoes. Again, that value of X is just the multiplier. Okay? So if you increase the price tenfold, you decrease the sales tenfold. That's all that needs. It's just balancing themselves out. So if I increase the price $10, I'd sell it for 70. Then I would be selling 20 fewer shoes. That's how those relate to one another. Sir?
So X is not a like cost, it's not like how many pairs or something, it's more like
It's the multi. It's how many times has it been increased or decreased. That's all. That's what I'm trying to. I'm really trying to hammer that point down here. Yes, ma'am.
So what I think, because it says like $60 per pair, I feel like it'd be 60x like after it says like per pair and
Yes, I see where you're going with that one. And you're right. If you have, if you sell 10 pairs of shoes, it would be 60 times 10, which gives you 600.
Yeah.
But the next line though says that prior to it, it said 200 pairs are sold at $60. So that means you're selling for $60 and you're going to sell 200 pairs of shoes. And you're right, for every pair of shoes you sell, you're making another $60. That's your baseline. That's if it was linear. That happens if it's a linear, if your sales figures was 60 times X, that means for every pair of shoes you sell, no matter that you're not changing your price, you're going to get your I can't spell the word total. Your total sales, your total income. And you're right about that. Because they said 200, 60 times 200 is 1,200, that's how we get that price. If it was 5 pair of shoes, they've made $300. Okay? But the difference becomes then is when they throw in the increase in price and a decrease in sales. That takes away from this linear style model and it throws it to the quadratic because there's 2 different things going on. So now, like we've said, this value of X becomes this common multiplier. The easiest way to set this problem up is to find, that we want to find the maximum monthly revenue. What's the maximum revenue? We need to find a maximum here. The maximum for these style problems, the easiest way to find it is just to do the axis of symmetry. Get the X value that's in the middle. Get your midpoint. It's always the easiest way to do this. Which basically means I'm going to set both of these equal to 0. Okay. In doing so, I get zeros at -60 and 100. Are we okay with that? Now, Trap, you're right. You can throw it in the calculator and do that as well.
but it doesn't look.
I'll look at it in 1 sec. Because I know some of these can look weird. Okay. Now, what we're going to do is that we know that we have zeros. It's going to go between here and here. At -60, it's 0. I make no money. At 100, it's 0. I make no money. That multiplier will make no income for me whatsoever. Okay, those 2 zeros make you nothing. Somewhere in between them is going to give me my maximum. So what's -60 plus 100? What's half of that? All we did here is we found the midpoint of that. Yeah.
Wait, 100 what would give you 0 what? Like,
The zeros, if I factored all this out, or FOILed all this out, and then I factored, if I graphed it, these would be my 2 zeros of the function. It crosses the x-axis at 100, it crosses the x-axis at -60. If I decrease the price 60 times, I'm not making any money because what's 60 plus -60? 0. What's 0 times whatever your sales figure is? 0. I'm not making any money at negative, if I decrease the price 60 times.
So you're making the same you're making no money at all?
Right. Because if you look at it, if you think about it in terms of, if I increase the price 100 times, that means I'm increasing my price to $160. At $160, that multiplier of 100 tells me that I'm going to sell 0 shoes. Nobody's going to pay $160 for those shoes. Okay, that's what that says.
So the zeros are like the increase of the price?
And not the increase of the price, it's the how many times has it been increased by? That common.
Oh, well, yeah, but since it's 1, right?
Right, but let's say it was 2. So
Okay,
if it was
then it would be 200, or
you got that better. It's that common multiplier. Okay, that's what those things mean. So I'm sorry, I'm moving away from that. So what happens is that when you look at these values of zeros, what they mean in terms of a quadratic style function, that's where you make no sales and you make no money, because nobody's going to pay $160 for a pair of shoes, right? Because I know people pay more than that. Oh, you do too? These were like $7,000. They weren't. They were like $40. I love it. So that's how you get it back. The maximum increase in price that you can get to make the most amount of money would be at 20, the halfway point. Okay. Now I know with the fire drill and all that other junk, what I would suggest you guys do, the review, that packet of word problems that we did the other day, re-go over some of those, re-look at some of those. We're going to kind of keep working on those again tomorrow real quick, okay? There should be a matching lighter somewhere. Right? Oh, there's one right on the left.
Well, 20 is X, so yeah, it'd be $80 per shoe and $140.
All right, we'll see you guys tomorrow. We'll continue. I'll make some more up for you.
So it is having,
I know.
is that's what I got on my calculator?
Re-look at some of those work problems. I didn't get as far as I wanted because of the fire drill thing. Remember that packet I gave you guys a week ago or so? The border problems and all those?
Yeah.
Re-look at those.
All right.
Do you want to leave this to charge and just grab it
Yeah.
later? Okay.